So the last kind of application that we are going to look at is called a ticket problem. That's just kind of the generic name for it. The example I'm going to show you does involve tickets, but it doesn't have to. It's just kind of like the same type of scenario. So again, I'm going to show you an example first, and then I'll kind of recap how we set these up, just because I think it's easier to see if you see an example first. So the question says the current price of an amateur theater ticket, sorry, that's not grammatically correct, is $20, and the venue typically sells 500 tickets. A survey found that for each $1 increase in ticket price, 10 fewer tickets are sold. Okay, so we want to find out a few things. We want to find out what is the number of increases that will maximize the revenue. We want to find out what the ticket price will be that will maximize revenue, and then what the actual maximum revenue will be. So the nice thing about these kinds of questions is that the first time you see it, you might be like, that's kind of weird. I wouldn't have thought to set it up like that, but you set them up the exact same way every time you do it. So what we're going to do is we are going to define our variables first. Okay, so we're going to let X be the number of price increases. And then it doesn't really matter what you call the other variable. I mean, you could call this whatever. You could use Y. I just usually say let R be the revenue just so that it matches. But you can use Y if you'd like to. Okay, and then what we want to do is we want to set up something that represents this. Okay, so we're going to have an equation that represents the revenue. Okay, so revenue equals, and then the way we set it up is we're always going to have two brackets, and one is going to be relating to the price and one is going to be relating to the number of items. Okay, so if we look at the question, it says that the current price is $20, and then we're looking at a $1 increase each time. Okay, so in my first bracket that represents price, I'm going to have 20 plus, you can write 1 if you want to, but I'm just going to write X. Okay, because each, again, X is representing the number of price increases, and my price increase each time is worth $1. Okay, so the first bracket is specifically relating to cost. Oops. Okay, so this is cost, and then my next bracket is going to relate to items. Okay, so now if we look at this, it says that the venue typically sells 500 tickets, and each time I increase the price, I sell 10 fewer tickets. Okay, so I'm losing 10 ticket sales each time the price is increased. Okay, so for this bracket, my items, in this case tickets, I'm going to have 500 and then minus 10 times X, okay, because again, X is the number of price increases, and so like if I have one price increase, I'm losing 10 tickets. If I have two price increases, I'm losing 20 tickets. Okay, so that's how you go about setting up your equation. So one bracket will always be the cost, okay, or the money, and then the other bracket is going to be the items. Like I said, in this case, it's tickets, but it's not always. Okay, so that's how you set up your equation. X will always be the number of price increases, R or whatever, Y can be your revenue, and then you have two brackets and you keep them isolated. Okay, so similar to with the area problems, you might be tempted to expand this to look more like a quadratic, but don't, because it will just make more work for you. So this is a quadratic, it's in factored form, and we want to maximize the revenue. So anytime you see maximize, that tells you you're going to find the vertex. So what we're going to do is we're going to let the revenue equal 0. Okay, so we're going to find the x-intercepts first. You don't have to be honest, I don't usually show this, like the let r equals 0. I just let each bracket equal 0 and solve. And for space, that's what I'm going to do here. Okay, so I'm going to let this bracket equal 0, so 20 plus x equals 0, which means x is negative 20. And then here I'll have 500 minus 10x equals 0. So I'd have 500 equals equals 10x, and then I'm dividing both sides by 10. So I will have 50 is equal to x. Okay, so those are the x-intercepts of my equation. And then because I want to maximize, I'm looking for the vertex. So I'm going to find my axis of symmetry, and actually I don't really need to find the vertex because I'm just looking for the number of price increases. Okay, so I'm gonna do my axis of symmetry. X is -20 plus 50 divided by 2. So -20 plus 50 is 30, and then 30 divided by 2 is 15. Okay, so that fully answers this part of the question, because again, x is my number of price increases, and this is asking me what is the number of price increases. Okay, so I can say therefore 15 price increases will maximize the revenue. So for this piece of the question, I don't actually have to find the other part of the vertex because it's just asking me what is the number of increases. Okay, so that's just the axis of symmetry. So next, I want to know what price the ticket will be when I'm maximizing the revenue. So for that, for this case, I know how many times I'm increasing the price. So I'm going to sub in x equals 15 into the cost. Okay, so my cost bracket. So I'm just gonna have 20 plus x. Okay, so then this is equal to 20 plus 15. So my cost is equal to $35. Okay, so I'm just subbing it into that first bracket that's related to cost because that's the question part B is asking me, is just what the actual ticket price is. Okay, so then we can say therefore a ticket price of $35 will maximize revenue. I could also ask you how many tickets will be sold to maximize the revenue, and in that case you would sub in your x value into the second bracket, into the items bracket. And then the last part here is I'm asking what is the actual revenue. Okay, so in this case I want to sub x equals 15 into r, my equation for r. Okay, so I'll have r equals, I already showed this part with it subbed in, but I'm just going to show it again. So 20 plus 35, and then my other bracket was 500 minus 10 times 15. Okay, and then I'm just calculating. So we already said that the first bracket was equal to 35. Oh wait, why did I write 35? Sorry, that should be 15. 15. Okay, this is 35. And then this is 500 minus 10 times 15 is 150. So my revenue is 35 times 500 minus 150 is 350, which gives me a revenue of $12,250. Okay, so this is the y value of our vertex, which again represents the maximum revenue. Okay, so then again I would have a sentence answer solving it, stating my answer. So therefore the max revenue is $12,250. Okay, and if we were to plot this on a graph on Desmos even, you could check this and you would see that your vertex would occur at 12,250. Okay, so your axis of symmetry is that x equals 15, that's the x value of the vertex, and then 12,250 is the y value of the vertex. Okay, so like I said, it might seem a little bit weird the first time you saw this example because you've never seen anything like this, but the way you set it up is always the same. Okay, so the way that you're going to recognize it's a ticket problem is pretty easy. Like I said, they're not always relating to tickets. That could be relating to any sort of like a bus fare or like I don't know, any sort of sales of anything, like like a t-shirt is this costs this much, and if you increase the price you sell this many more or whatever. So it's always going to be talking about objects for sale. It'll talk about revenue and cost, and it will mention, the biggest thing that gives it away is that it will always mention price increase or a price decrease. Okay, so we didn't look at an example of that, but sometimes it represents a price decrease. So you set it up the same way, you just would have a subtraction sign instead of an addition in your cost bracket. Okay, and then, like I said, the way you set it up is always the same. So you let X be the number of price increases or price decreases, depending on the question. And then to set up your equation, you're always going to have revenue equals, your one bracket will be the cost. Okay, your other bracket is going to be the items. Each bracket has an X. Okay, so you'd have like R equals, and then just to be more specific, you'd have like your initial cost plus or minus something X. Okay, and that something X is the value, like the dollar value of the increase or decrease. Okay, so in our question we had, this is a number, sorry, I guess I should say that. This, in our example that we did, this was just a 1 because each price increase was worth $1. And then your other bracket, you'd have the initial number of items plus or minus the, so again, some number multiplied by X. And then that number is representing the number of items gained or lost, again, depending on the situation. So typically if your price is increasing, you're losing out on items that you sell because you lose customers as it becomes more expensive. Whereas if you are decreasing the price, you will gain items because the cheaper things are, the more people that want to buy it. Okay, but that's kind of always the formula for how you set it up. One bracket is cost, one bracket is items. Okay, so when you're highlighting the question, you'll notice even in mine here, I used one color for my dollar amounts and then another color for my actual items. So it's important to make sure that you don't mix cost and items in one bracket, right? That you keep them separate, a cost bracket and an items bracket. Each bracket has an X in it, and you don't need to expand it to a standard form equation because we're always going to be maximizing the revenue, and we need the X intercepts for that, so we can just leave it in factored form. Okay, so that is how you solve a ticket problem and how you recognize it. Okay, so again, make sure you practice some of those questions. There will be some for you to try to hand in. Once you've done a few of them, like I said, the method is the same every time, so they become pretty repetitive and easy to recognize and to set up. And with that, we are done all of the content of this course. So there's some review questions for you to do, and then we will get ready to do our test and our culminating assignment tomorrow.